All right, so I have limits of integration and what I need to do if I change and do u substitution. So it is not necessary to do u substitution in doing these two because you have got the La Jolla theorem memorized. So this gives me a negative 1/2 e to the negative 2x. And here I get e to the negative 2x. And here I get a negative 3 cosine of x over 3. And then I just get to go and use 0 and pi. I started my integral in x's, I ended in x's, so I don't need to change anything. So I get negative 1/2 e to the negative 2 pi, and then subtract off 3, and I have cosine of pi over 3. And we'll figure out what that is in the next step. Subtract off, be careful with the zeros, right? For both of these, neither of them are 0. So if I put in e to the 0 here, I get e to the 0, which is 1. So I get a negative 1/2. Put in 0 here, I get cosine of 0, which is 1. So I get a negative 3. All right, so let's simplify this a little bit. So I get this does not change any. So just leave this in your answer. So e to the negative 2 pi. Cosine of pi over 3, you know, is 1/2. So that gives me a minus 3/2. So this negative will be positive. So I'll get a 3, meant to write a half there. There's a half, 3/2. And so this gives me a negative 7/2, but it turns positive, so positive 7/2. So just clean it up a little bit, e to the negative 2 pi. And then plus 4/2 or just plus 2. Turned out to be kind of nice. All right, so here we go. So this again, I know this antiderivative is going to be negative 1 over pi cosecant of pi x because I know La Jolla theorem. So 1/6 and 1/2. So I get negative 1 over pi cosecant of pi over 2. Subtract off a negative 1 over pi cosecant of pi over 6. So this gives me a negative 1 over pi, because I know cosecant of pi over 2 is 1, and then cosecant of pi over 2 is 2 over root 3, no, 2, sorry, 2, 1 over 1/2, so 2. So I get a negative 3 over pi. All right, so ugly things, but we don't have to change limits of integration. It's good to kind of practice ugly things. So here I get 1/2 secant of 2x by La Jolla theorem. So 1/2 secant of, this will be pi over 3 if I put in the pi over 6 in here. Subtract off 1/2 secant of 0, which I know is 1. So this gives me a 1/2 times a 2 minus a 1/2, and that gives me 1/2 as the answer. All right, so those are just some ugly integrals, little details working in the trig functions. I want to make sure you're good with. Okay, so let's look at what's happening here. So on this one here, I must do a u substitution, so I did it. So here is my u is equal to the exponent, du is negative 4x, and here's my du, negative 1/4 du is x dx. So e to the u du, you can see how we can get that out of this. So then I want to change the limits. So here's my limits of integration of x equals 0 and x equal 1, and I want to change the limits so that they go with the letter u. So du means these numbers here have to be u limits of integration. So I substitute x equals 0 into the conversion factor. So the conversion was the initial u substitution. So if I put x equals 0 in here, I get u equals 0. If I put x equal 1 into this, I get u equal negative 2. So notice I have the negative number on the top. So what we can do is we can switch the limits of integration and put a negative in the front. So I did that, and then I took the antiderivative, and then I plugged in 0, and then subtracted off, plugging in the negative 2. So you have to remember, do not put the x's back in when you change the limits of integration. All right, so here I let u equal the sine of x. Du is cosine, so I end up getting integral of sine of u du. So changing the limits of integration, put this x equals 0 in right there to get u equals 0. Put this x equal pi over 2 in right there to get u equal 1. So this is 0 to 1 of sine of u du. So that's negative cosine. And it is completely appropriate to leave negative cosine of 1 in there and not put it on your calculator. All right. Let's look at this next one. So what you can do, just to give you an option, this is the big or, what you could do to redoing the same problem is that you could do the u substitution and you get to here. So after the u substitution, you take the antiderivative. Then what you could do is you could put the x's back in, then put the original limits of integration, which go with x's back in, and then take the antiderivative. So it turns out to be the same. So you get to choose one or the other. All right, so something like this, you don't have to do a u substitution because you recognize it, so I don't need to go change the limits. So you see that this is 1/2 sine of 2x between pi over 6 and pi over 4. So 1/2, and this gives me sine of pi over 2. Subtract 1/2, this will give me sine of pi over 3. So this gives me 1/2 minus 1/2 times root 3 over 2. So no changing of limits needed. This one here, number 8, we do need to change the limits of integration because this is going to be a more challenging integral. All right, so I can see by looking at this, this is cosine of 4x all to the third power. So I'm going to let u equal cosine of 4x. So du is negative 4 sine of 4x dx. So negative 1/4 du is sine of 4x dx. All right, so let's do it. So I have negative 1/4 u to the third du. Okay, so now I'm going to change the limits of integration. So if I put x equals 0 into this conversion factor, I get 1. If I put x equal pi over 4 into this, I get cosine of pi, which is negative 1. So I'm going to take the time to rewrite, switch the limits of integration, and then I can take the antiderivative. So I get 1/16, and I'm not putting the x's back in. I'm going to take 1 to the 4th power, and then I'm going to subtract off negative 1 to the 4th power. So that gives me, oh my goodness, 0. All for nothing.